Hello and welcome back to Supply Chain. We're doing parts D and E for question number 25. So to calculate the probability of having 4 or more students in line or being served is through this formula here. P of n equals to 1 minus lambda over mu times lambda over mu to the power of n. And so to calculate this, we have to write out this long formula here. This long formula represents the probability of having 0, 1, 2, or 3 students in the line. So there's this magical thing in math, and it's known as taking the common factor. And we can notice that here, this is the common factor in all of the terms, and then we can take that and separate it, move it to the outside, and then all we're left with are the lambda over mu to the power of 0, 1, 2, and 3. And then when we plug in the numbers, we get 0.8 or 80%. And so this isn't the final answer because 80% actually represents the probability that there are 0 students, 1 student, 2, or 3 students. So that's the probability of having these many students in line. But to find out the probability of having more than these number of students in line, we have to subtract it by 1. So 1 minus 0.8, 1 being 100%, we're going to get 0.2, and that's 20%. And so 20% is the probability of having 4 or more students. Moving on to part E, we can see that when the lambda changes to 6, when the arrival of students changes to 6 per hour on average, what will the new length of the line be? So when we plug in the formula, plug in 6 into the formula, we're going to notice that it's going to give us 36. This is the new average length of the line. And we can also notice that when we calculate the free time of the graduate student serving those students, it's going to be 0 because his capacity utilization rate is going to be 1, because it's going to be 6 over 6, which is going to give us 1, and that 1 minus 1 is going to be 0, so he's technically no free time. And so yeah, that's it for parts D and E. Thank you for watching.